Hey Lisa, so I think by short equation you mean because it's missing a term here. And so our standard form for a quadratic or a parabola is ax squared plus bx plus c. And so in this case, the c would be 0, which won't matter when we're finding the vertex, but I think the next question after this one, it's missing b, which I bet is also messing up in terms of finding the vertex. So let's take a look at this on the homework itself. Is that the same? Yep, it is. Okay. Oops. There we go. So it looks like you're able to get the x-intercepts okay. So you set this y equal to 0 and then factored and solved. Let me get this written down over here. And then, so 0 and 6 are going to be your x-intercepts, so right here and right here. This one that's 0 also counts as a y-intercept. Remember, to find the y-intercept, we would let x equal 0, and then we plug in and solve for y. So y would equal 0 squared plus 6 times 0. So y equals 0. And you don't really have to do that if you already found the x-intercept, because if you have the point 0, 0, it counts both as an x-intercept and then also a y-intercept. But so there's your y-intercept. So now you got this point and this point. And then from there you just need to find the vertex. Well, one thing, the x is going to be -3 because it's halfway in between, but let's find that analytically. So for our vertex, we have x equals -b over 2a. So we'll pop up here to our original, so that'd be -6 over, there's an invisible 1 right there, so 2 times 1. And that's that -3 that we're like, well, it's got to kind of be halfway in between the points. And then to find the y that goes with that, we plug our x back in, we solve for y. So then we'll go y equals -3, and then careful with that squared, it's going to be a positive because we're -3 times -3, plus 6 times -3. So that's going to be +9 right there, and -18, and 9 minus 18 would be -9. So our vertex should be at -3 and -9. And I have the graph right here, so I'll pull that up. So there you can see there's the vertex. We'd go -3, -9, that'd be our first point. And then we could either use, if you're graphing this on paper like the exam, you would put both of those x-intercepts down and that vertex, and boom, draw a curve between them, and you got it. For the computer, you just need the vertex and one other point, and it fills in the other one for you. But for the exam situation, yeah, definitely you would be graphing your vertex, and then you have to be careful to recognize what those x-intercepts mean in terms of the graphing. When you solve that, you would have got x is 0, or x is -6, pardon me. And so that means you have the points 0, 0, and the point -6, 0, because that's, you're letting your y equal 0, and then solving for those two x's that go with it. So with those 3 points in terms of an exam, boom, that got you your graph. Let's take a look at this next one. 13 you got. It was 14. I think 15 is pretty similar as well, yeah. So, just see what's coming up. Okay. So for 14, yeah, 14 and 15 are pretty much the same. So we got y equals 1 minus x squared. So if we're going to find the x-intercepts, we would let y equal 0. And then I don't love a -x squared, so I'm going to bring that over to this side. And that equals 1. So from there, I have 2 ways I can solve that. So the first one would just be to take the square root of both sides. And that would give me x equals plus or minus 1. So remember, we let y equal 0, and I really encourage you to be in the habit of writing out these x-intercepts as ordered pairs in terms of your notes, because it will help you when you go to graph. So 1, 0, and -1, 0 would be your x-intercepts. The other way to solve this is, again, I don't like that negative term, the negative x squared. So you could also bring everything over to this side, and it would be positive x squared minus 1 equals 0. And then you could factor x plus 1, x minus 1, and then there's the same x equals negative 1, x equals positive 1 that we got down here. So either of those ways is totally fine for solving 14 and 15. For the y-intercept, if we let x equals 0, so y-intercept, we let x equals 0, and then that would give us y equals 1 minus 0, and that would be y equals 1. So when x was 0, y was 1. So that is our y-intercept. So there's our x-intercepts. And this is exactly, I think, probably what I would ask on a test. I'd ask you to identify all these things to help you hopefully get enough points to then get it graphed. And then find the vertex. Let's see, let me scroll up and I'll rewrite that. So it was y equals 1 minus x squared. First, let's write this in the other order, negative x squared plus 1. And for this one, we don't have an x term, we don't have that b. If I wrote it in there, it would look like, if I wrote all the numbers out, it would look like negative 1x squared plus 0x, because there's nothing there, plus 1. And then this is our a and our b and our c. So if we do x equals negative b over 2a, that's cool, that's 0. So 0 over doesn't matter, 2 times negative 1, that's going to be 0. And so the y-intercept is going to turn out to be our vertex, because when I plug 0 back in, let me scroll back up there now, right, that's exactly what we did up here. We let x equal 0 and we solved and we got y. So this is both the y-intercept and the vertex, which can happen. So it just means it's symmetric about the y-axis. So in terms of graphing this, then we would have 0, 1, x is 0, y is 1, and then our intercepts up there were 1 and negative 1, and so you can see if I put it here on 1, there's the negative 1 on that side. And then that's pretty much the same thing with this one. The 15s are going to be plus or minus 15s. That probably makes, if you go back and watch what I did with the 1s, it's the same thing there. And the rest of that one's pretty much the same. On this last one, let me help with the x-intercepts a little bit there. The vertex and the y are pretty straightforward. The number on the end is going to be the y-intercept, because when you let x equal 0, that's all it's going to survive. For the vertex, you just do your negative b over 2a and plug it back in. And the solving for the x-intercepts on that is a little bit harder. So let's do, actually let's do 0 equals negative 2x squared plus 8x minus 6. Again, I do not like a negative leading term. It makes it really hard to factor. And so for at least while I'm factoring, I'm going to multiply both sides of this by negative 1. So, and I could also bring everything over to the other side and rewrite it as a positive that way. But I'm just trying to get that negative off of the 2 and get it applied to the rest instead. So that's going to be positive 2x squared minus 8x and then plus 6. And it looks like there's a common factor of 2 going on. So let's factor that out and see if it gets us anywhere better. So that'll be minus 4x, and that'd be plus 3. Yeah, that's better. And so then we can say what multiplies to 3, it adds to be negative 4. So x minus 1 and x minus 3. And so we'd have intercepts at 1 and 3. Or if we want to think of that as points on a graph, it would be 1, 0, comma, and then 3, 0. And like I said, the rest of that is pretty much the exact same as what we just did in those last examples. Cool, hopefully that helps out.